Hello again, everybody. Thanks for joining us. So in this session, I wanted to talk about one of the animated GIFs that were put together by Ivan and Dara. Basically, what we did in the course is we're trying to explain a couple of concepts around feature detection and an image pyramid. And so we said, why don't we just use this time and talk through exactly what's happening here, because it's important and it'll give you really good conceptual overview and something for your tool set in terms of thinking about these techniques visually. So with that, I'll just hand over to Ivan.
Thank you, Andrew. Okay, so what we have here is an image of a person skiing. It's a nice scene.
Yeah.
And we have a feature detector. So this blue box here is going to be scanning our image looking for people. And it's going to be looking for a person of approximately that size within the image.
The detector has been trained to say if the object we're looking for shows up in our detector, and what you've learned about what we're looking for, then it'll
say yes, person here.
Got it.
So what we're going to do is we're going to slide that detector across the image horizontally.
Okay.
And when we get to the end, we're going to come back to the left-hand side, shift down a tiny bit vertically, and then slide over again.
Okay.
Now, each of these slides are actually going to overlap.
Got it. So it's shifting in a window.
Yeah. So we're going to have a very, very large number of potential locations for the person within this image.
Okay. So I get the idea. We're scanning. We're going horizontally. We're going vertically across this image, looking for whatever we've trained this detector to look for. In this instance, a person. What about in the background, I have someone really small because they're really far away, or another I've seen before, someone is right in front of the camera, getting in sort of really large in this image. What happens there? Because the detector looks like it's of a particular size, but what happens in this instance?
That's a really good question. So we have broadly speaking, two possible techniques we can use here. We can scale the detector, we can make it bigger, or smaller, or we can keep the detector a fixed size and instead scale the image.
Okay.
So an algorithm like Viola Jones will scale the detector because it's very cheap computationally for it to do so.
Okay.
Whereas an algorithm such as the HOG, the histogram of oriented gradients, typically it scales the image. Now if you keep scaling your image and making it smaller, and then conceptually think about stacking them, one on top of the other.
Okay.
That's what's called the image pyramid.
That's what we mean with a pyramid. Okay, so very interesting. I think what we'll do is we'll move on to that lovely animated GIF you put together for our students, just to see this in action. There's a great explanation. Let's go live to the image. Okay, so here we go.
Okay, so we're searching all the possible locations here. Anytime we find one, we're going to mark it. We'll just leave a red box behind. So there we detected our person. And what you'll notice is on any particular scale, you might have more than one detection. So you'll have to fuse those into a coherent bounding box at the end. And we talked to this in the lab.
Okay, so as we're moving, you see we've shifted up, the image has changed size, we scan again. So this is building
notice
this.
In each case, the image detector, the feature
never
detector
changes.
stays the same aspect, the same size.
Okay, and it goes all the way, and then it builds this pyramid, and then we're done.
Now we've got to the point where the person's too small to fill the bounding box, or to fill the
and we didn't
bounding
detect her
box
there.
of the detector, and we don't see her. Exactly.
Ah, interesting.
And that shows the importance of the scale.
Got it.
You need to have the scale more or less approximate to the scale of the person within the feature detector.
So for Viola Jones, for HOG, we're seeing here, this is pretty much a rote. We're going through the entire image. And so what happens when the images are, high resolution on that scale? What do we do there?
So this particular image pyramid you could use with multiple different types or different categories of object classifier.
Okay.
If you are taking, say, for example, a 1920 by 1080, a 1080p image.
Yeah.
And you're scaling a small feature descriptor across that, you're going to have billions of potential locations.
Because you're moving kind of one pixel at a time across and down, a couple of pixels.
Your stride is configurable, but typically a couple of pixels at a time. And if you multiply an expensive detector by billions of potential positions, you end up with a huge computational burden.
So expensive detector, you mean it's computationally expensive, it takes its decision.
Yes. So for example, something like a convolutional neural net, a deep net. So instead, what you can do is you can use other techniques called region proposals to look for where there are a lot of color changes, a lot of edges, a lot of features in the image.
So we're giving our search mechanism, our feature detector, some hints as to where they may find the object.
If you think of the search space of every possible blue box location within this image pyramid, instead we're providing just a couple.
Great.
Check here.
Fantastic.
And that reduces the computational load. It allows us to run more expensive classifiers on a smaller search space and be more confident of our results.
Fantastic. Well, that's a really in-depth view into this animated GIF. I hope you out there found that really interesting, and these techniques are really come to life for me, in particular when they're visual. So, Ivan, thank you very much.
You're welcome.
And thank you, everybody, and we'll see you again soon.